Hi, this is Danielle again with another calculus problem here to help you through and solve together. So with this equation or problem that we were given today, we're being asked to find the position of a particle, and we have been given this acceleration function here as well as some values here for our position. So to start out today, what we're going to need to do is first start by finding our velocity function here, given our acceleration function. And then from there, we can go ahead and find our position function. So first, we'll start by taking the antiderivative of that acceleration function. And that's going to give us our velocity. So here we'll start with our first term, which is the 10 sine t. And what we would need to have to give us that value would be negative 10 cosine t. So if we were to take the derivative here of the cosine t, our 10 is just a constant. So that will just stay in front of our term here. And negative cosine t is going to end up being sine t. And then here on the other side, we have another constant. And the antiderivative of cosine is going to be sine. And then we do need to go ahead and add on a constant variable. So I'm going to use c here. So then just to double check again, if we were to take the derivative of this here, we would get here 10 sine t. And then here, the derivative of sine t is going to be cosine t. And then our constant stays in front. And then this c here would just fall off. So now from here, don't worry about solving for your c right now. Go ahead and find our position function by taking the antiderivative again. So then we'll use s for our position function. And the antiderivative of a negative cosine is going to be a negative sine. And again, our constant's just going to stay right out in front there. And then here for sine, if we have cosine of x, then our antiderivative would be negative sine x. But here we have a positive sign, so that's actually going to need us to have our antiderivative as a negative cosine plus c of x plus another constant, which this time I'll go ahead and label as d. All right, so now we have our position function, but we're missing some variables. Now we can go ahead and use those given values here for our position. So first we'll solve for 0. So we'll go ahead and plug 0 into all of our t values. All right. And so here, sine of 0 is just going to end up being 0. So this term won't end up counting towards our value here. Oh, I do want to actually go ahead and write out here. This is equal to 0. There we go. And then cosine of 0 here is going to end up being 1. So here we'll end up having 1 times negative 3. So I'm going to go ahead and actually write that one down here. And here c is being multiplied by 0, so that's going to end up falling off. So then we end up with just this d as well here. So then we end up having negative 3 plus d equals 0. Well, that just ends up being d is equal to 3. Now we can also go ahead and solve for 2 pi. And then now here, instead of writing a d, I'll go ahead and plug in my 3. And we see that 2 pi ends up being equal to 12. And then here, so 2 pi is actually going to give us the same values here for our sine and cosine as it did for 0. So 0 times the negative 10 is just going to end up still being 0. Over here, we'll still have the negative 3. But this time we do have a positive 3. So those 3's are going to end up canceling each other out. So we'll just be left with c times 2 pi is equal to 12. Or c is equal to 12 over 2 pi, which we can also simplify to c is equal to 6 over pi. All right, so now we have that, and we can go ahead and plug that last value into our equation. So then we have our position function is negative 10 sine t minus 3 cosine t plus, this is where we use our pi, or 6 over pi, t plus 3. And there is your final position function.